What if, one day, a fragment from another star passed through our solar system, and instead of dimming as it neared the sun, it flared brighter, turning bluer than the sun itself? That's exactly what has just happened. The interstellar object 3I, Atlas, during its close pass on October 29, 2025, did something no comet has ever done. It brightened with impossible speed, and its light shifted toward an intense electric blue. Harvard astrophysicist Avi Loeb looked at the new data and asked the question that now echoes through the scientific world. If there's no sign of outgassing, then perhaps we are witnessing a form of energy not yet understood. You see, the images from multiple space observatories, Stereo, A, SOHO, GOES 19 all agree. A halo 300,000 kilometers wide surrounds the object, but there is no trace of escaping gas or dust. The brightness increased not gradually, but following an extraordinary pattern inversely, with distance to the power of 7.5. And that blue color, that's the real mystery. In physics, colder objects shine redder, not bluer. Yet here was something dimmer, smaller, and colder than the sun, glowing in hues that belong to hotter plasma, to stars, to the electric breath of energy itself. Loeb suggested we might be looking at a new kind of process, perhaps even a design structure, something that converts solar radiation into light in ways we don't yet comprehend. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple: to help you drift off to sleep while exploring the wonders of science. Where are you on the map? Let me know where you are in the world and what time it is in the comments. It's always fascinating to see who's joining us from all around the world. So, let's continue. When the first images came in, you could almost feel the tension in the room, scientists leaning closer to their screens, the quiet hum of data unfolding from millions of miles away. And there it was, 3I Atlas, glowing like a living ember against the black sea of space. Well, not just glowing, but brightening rapidly, unpredictably, almost defiantly, as it curved toward the Sunday. What was supposed to be a faint, icy wanderer from another star was instead turning into a cosmic enigma. It wasn't just a comet, it was a statement, a question. The data, coming from the Stereo spacecraft, from SOHO's coronagraph, and from GOES 19's compact coronagraph, all told the same improbable story. The brightness of 3I Atlas didn't follow the familiar law of comets, where sunlight vaporizes ice and throws off a pale, dusty halo. No. The brightness rose with the inverse of distance to the power of 7.5. That number 7.5 was not a mere detail. It was a crack in the wall of our expectations. It said that something was feeding this object with energy far faster, far more efficiently than any solar reflection or sublimation could account for. And that's the thing: there was no sign of escaping gas. None. No dusty jets, no icy tail flickering away from the Sunday. Instead, around it spread a faint halo, 300,000 kilometers across, as though the space around the object itself had caught fire. Avi Loeb, well, he said it plainly, if there's no outgassing, then perhaps we are witnessing a form of energy not yet understood. It's not that he claimed it was artificial not yet, but that he was willing to name what most of us hesitate to admit: we don't know. And that humility, that simple admission of mystery, is where science begins to breathe again. The images showed something else, something even stranger: the color, a deep, electric blue. And, that color carried with it an uncomfortable truth, because blue light, you see, belongs to energy, to heat, to violence. A blue star burns hotter than a red one. A blue flame is more ferocious than a red ember. Yet 3I Atlas was supposed to be cold. It should have been dim, red, dusty, not shining with the radiance of plasma. So what was powering it? Was it reflecting something, emitting something, transforming sunlight in a way we've never seen? When Loeb spoke about unexplained energy, he was not being poetic. The instruments measured spectral signatures inconsistent with reflected sunlight alone. The light appeared to contain a self-emissive component, as if the object itself, or the space around it, were generating photons. And that's a remarkable thought, that the vacuum around a foreign rock might, under the right conditions, begin to glow. You might imagine 3i Atlas like a seed thrown from another garden of stars, now blooming near our Sunday. Its brightness wasn't an illusion. The coronagraphs saw it, the heliospheric images confirmed it, and even after accounting for scattering, calibration, and optical noise, the data held. Every model failed to reproduce the curve. It was, in the language of physics, an outlier. In the language of awe, it was a miracle in motion. And yet, scientists are cautious creatures. They tested everything: the imaging pipeline, the CCD sensitivity, the angle of observation. They even considered whether stray sunlight from the solar corona could mimic the effect. But no, the halo persisted, stationary around the object, extending evenly in all directions. Whatever this was, it was real. It makes you wonder, doesn't it? Whether energy might exist in forms we haven't yet catalogued. Maybe the object contained materials that interact with sunlight in a non-linear way, releasing energy rather than absorbing it. Maybe it was, well, some kind of superconductive metal or crystalline lattice that channels electromagnetic flux differently from ice or rock. Or maybe, and this is the kind of thought that keeps people like Loeb awake at night, maybe it wasn't just reflecting the sun, but amplifying it. And there's something haunting about that idea. Because if 3i Atlas can amplify sunlight, if it can brighten faster than any known body without losing mass, then we're looking at a phenomenon that sits right on the border between nature and design. It's not just physics anymore, it's philosophy. It's the question of intention written in the sky. But, before we leap to conclusions, the beauty of this moment is that it forces us to look again at data, at light, at what we call natural. Every generation of scientists has its frontier of ignorance. For Newton, it was gravity. For Einstein, space-time. For us, perhaps, it's the quiet fire inside 3i Atlas. You see, the absence of gas jets means we can't explain the increase in luminosity through conventional outgassing models. The observed blue hue cannot be replicated by dust scattering, which normally reddens the light. The energy output doesn't fit the curve of thermal radiation from a cooling body. So, what's left? A process that draws power from within or, from interaction with the solar wind in ways we've not yet theorized. Some researchers have begun to explore the idea of induced currents, that maybe the magnetic field of the sun interacts with a conductive surface, creating plasma discharges around the object. Others whisper of chemical reactions within the rock, or the decay of radioactive isotopes generating a faint luminosity. But none of these explain the blueness, that crisp stellar blue which, as Loeb points out, suggests photon energies far exceeding any reasonable temperature on that small cold surface. So we're left, again, with wonder. The kind of wonder that makes you pause in the middle of the night, step outside, and, look up. Because that light, that impossible blue, is more than just data points. It's a conversation between the known and the unknown, between what we can measure and what we can only feel. Loeb once said that the universe is not obligated to make sense to us. I suppose that's true. The universe doesn't explain itself. It just is. It moves, it glows, it whispers through light. And sometimes, if we're patient, it lets us listen. And yet, there's something deeply human about this search, this refusal to stop asking. We look at an interstellar rock and see not just a mystery, but a mirror, because, well, perhaps 3i Atlas is teaching us more about our minds than about matter. Our need for explanation, our discomfort with the unknown, that's what flares within us when we meet a thing like this. The blue halo, the rising brightness, the silence of space around it, all of these feel like metaphors for the scientific spirit itself, fragile, luminous, always reaching outward into the dark. We don't know what powers it, not yet, but that's what makes it beautiful. And maybe that's why Loeb's phrase, unexplained energy, resonates so deeply. It's not just about physics, it's about curiosity, about the refusal to let the sky remain silent. The unexplained is not a barrier, it's an invitation. So, as 3i Atlas continues its journey beyond the sun, carrying its halo of questions, we're left watching, measuring, wondering. The data flows in like tides, each bit a glimmer of understanding, each frame a hint of what might come next. And somewhere, beyond all that light, another question begins to rise, about color, about heat, about the meaning of blue itself. And that question about the color, about that haunting, impossible blue, it lingered. It lingered not just in the data, but in our minds. You see, in physics, color is never just color. It's a temperature, a frequency, a code written in light. And, that's why 3-eye atlas confuses us so much. Because the blue it radiates shouldn't be there. It breaks the quiet logic that colder things shine redder, warmer things shine bluer. This interstellar object should be dim, reddish, coated with dust and ice that scatter sunlight into warmth. But it isn't. It's not red, it's not fading, it's blue, fiercely blue. And that, well, that turns everything we know upside down. Blue light means energy. It means high-frequency photons. It means heat, the kind of heat we see in stars, in electric arcs, in ionized plasma streaming through magnetic fields. But 3-eye atlas is, nothing like that. Its surface is frigid, hundreds of degrees below freezing. Its body, composed of rock, metal, or ice, cannot emit photons at those energies. So what's happening? Is it reflecting sunlight in some strange way, or creating its own light entirely? That's the puzzle. And, the more we think about it, the stranger it becomes. We know that dust usually makes light redder. When sunlight passes through cosmic dust, the shorter blue wavelengths are scattered away, leaving a warmer, softer hue. It's what makes sunsets red. It's what makes distant galaxies glow amber through interstellar haze. But with 3-eye atlas, it's reversed. The light grew bluer as the object brightened, as if dust weren't absorbing blue, but generating it. That's not scattering anymore. That's emission. That's active light, not reflected light. And, well, that distinction changes everything. Avi Loeb described this shift as an anomaly, the 9th in a growing list that already includes its unexpected trajectory, its acceleration, and now its spectral transformation. If it's bluer than the sun, he said, then it's producing something. And that's a provocative thought. Because it means we might not be looking at a passive traveler illuminated by the sun, but an active system, a process, maybe even a mechanism, radiating light of its own. It's not just an object, it's an event. Some theorists tried to explain it as fluorescence, sunlight absorbed and re-emitted at shorter wavelengths by volatile compounds. But that would require gases, and there are none. No outgassing jets, no coma, no tail. Others wondered if plasma interactions could account for it. Perhaps solar wind particles slamming into magnetic fields near the object's surface could excite ions to glow. But again, the geometry doesn't fit. The halo is too smooth, too symmetric, too constant over time. Plasma flickers. This glowed. It's almost poetic, really the idea that something cold can burn with blue fire. It's not supposed to happen, but it does. It's like the universe whispering, "Your rules, they're not mine." And, maybe it's trying to tell us something. Maybe color, temperature, and energy aren't as fixed as we imagine. Maybe, under the right conditions, a body can generate light not from heat, but from structure, from electromagnetic resonance, or from some unknown quantum interaction. You see, the blue of 3-eye atlas is more than visual. It's symbolic. It's the color of contradiction. It tells us that physics, as elegant as it is still a translation, and sometimes the universe speaks in dialects we don't yet understand. So, we listen. We stare at the spectrum, the wavelengths, the shifting hues that shouldn't exist. We measure again and again, hoping that repetition might make the impossible familiar. But it doesn't. Each measurement only deepens the mystery. And, if you think about it, this isn't the first time light has betrayed us. In the 19th century, scientists looked at the sun's spectrum and found dark lines they couldn't explain until they realized those were the fingerprints of elements. In the 20th, we saw quasars and thought they were nearby stars until we discovered their redshift placed them billions of light years away. And now, In the 21st, we look at a comet from another star and see blue where there should be red. The pattern continues. The universe confuses us, and through confusion, we learn. Still, the implications are profound. If the blue hue indicates high-energy photons, then energy must be released somewhere. If it's not from heat or chemistry, then perhaps it's from fields electromagnetic, gravitational, quantum. Perhaps 3I Atlas is surrounded by a plasma sheath energized by induced currents. Or perhaps, it's interacting with solar radiation pressure in a non-linear way, converting momentum into light. Whatever it is, the symmetry and persistence suggest order, not chaos, a process stable enough to maintain color over time. That's what draws Loeb's curiosity. Unexplained energy isn't just a label. It's an invitation to reconsider what energy can be. We tend to think of it as heat, or motion, or radiation. But maybe it's also information. Maybe the object is responding to its environment, adjusting, resonating. If that sounds strange, well, so did quantum entanglement once. And, well, there's something almost artistic about how 3I Atlas behaves. It's not violent like a supernova, not chaotic like a flare. It's gentle, steady, deliberate, the kind of brightness that feels intentional. You could almost imagine it breathing, expanding, and contracting with invisible tides of force. It's not just a comet performing physics, it's a choreography of light. We can't escape the human urge to interpret it, of course. When something moves against the grain of nature, we project meaning onto it. Maybe it's alive, we think. Maybe it's built. But perhaps the truth is simpler and stranger. Maybe this is nature in a form we've never seen before. Self-organizing, self-emitting, a spontaneous order born from alien conditions. Nature isn't obligated to repeat herself. And yet, the color blue carries with it an emotional resonance that's hard to ignore. It's the color of distance, of longing, of the edge of things, oceans, skies, twilight. It makes sense that the first truly interstellar object to glow like this would choose that color. The color of the in-between, the color of the unknown. So we find ourselves caught between science and poetry, between data and wonder. The instruments tell us one thing, our intuition tells another. The graphs rise, the numbers match, but the feeling remains that we're glimpsing something beyond comprehension. And, that's what makes it beautiful. Because science without mystery is arithmetic, and mystery without science is superstition. 3. I Atlas lives in the narrow space between them. If you could stand near it, if somehow you could float alongside that halo of blue, what would you see? The sun would blaze behind it, yes, but around this silent traveler, the light would shimmer, not scatter. It would feel alive. The particles, charged and restless, would trace invisible lines of force, weaving a shell of energy that breathes with the solar wind. You'd feel the faint hum of electromagnetic pressure, the whisper of cosmic electricity. You'd realize, that light is not still. It's alive, like thought, like memory. And that's what this whole phenomenon forces us to reconsider, the relationship between matter and light, between what is and what appears. If blue can emerge from cold, if brightness can rise without fuel, then maybe our equations are missing something. Maybe energy can emerge from order, not just chaos. Maybe there's a hidden symmetry, a kind of resonance that allows a body to borrow from the field around it, to glow without burning. It's unsettling. But then again, so was every great discovery. When we first detected radio waves from pulsars, people thought they were signals from extraterrestrial intelligence. When we saw the first black hole shadow, it looked too perfect to be real. And now, when we see blue light from a frozen object, we're reminded again that the universe doesn't have to make sense to us. It simply invites us to understand. The paradox of 3I Atlas, you see, is not just about physics. It's about perception. We expect nature to behave like a teacher, repeating lessons until we understand. But sometimes she behaves like an artist, offering something new, something that refuses to fit the frame. The blue light is her brushstroke, and we, standing beneath it, are left to wonder, is this an accident of chemistry, or the signature of something larger, a new form of order, a new law waiting to be written? The more we stare into that light, the more we realize that we're not just studying an object, we're studying our own limits. The limits of sight, of theory, of imagination. It's not only the comet that glows, it's our curiosity itself, ignited by the impossible. And somewhere in that growing brightness, somewhere in that electric blue, the next question is already forming, not about color anymore, but about motion, about what drives this surge of light, about why, as it neared the sun. 3. Atlas defied the very laws that once seemed unbreakable. So, when we talk about what drives that strange, blinding blue light, we find ourselves face to face with another impossibility. The numbers, the clean lines of theory, all begin to shake. Because, when astronomers plotted the brightness of 3I Atlas against its distance from the sun, the curve didn't match anything in the textbooks. Not the usual comet law, not reflection, not thermal radiation. Instead, it climbed faster, far faster, scaling with the inverse of distance to the power of 7.5. That's not a slope, it's a leap. That's not gradual warming, it's something surging, something accelerating beyond reason. Comets, you see, usually brighten as they approach the Sunday. The closer they come, the more sunlight hits their frozen surfaces, vaporizing ice, releasing dust, forming those long luminous tails we know so well. The rule of thumb, a comforting old one, says brightness increases roughly as distance to the power of -3 or -4. That's neat, predictable, a law that's worked for centuries, but 3I Atlas refused. It didn't just brighten, it erupted, a steep mathematical cliff of light. And that's where the problem begins, because when the data keeps saying no, theory starts to tremble. We tried everything: outgassing rates, reflective albedo variations, even instrumental bias. Nothing worked. It's as if the object were amplifying sunlight through some hidden engine. And that would mean it wasn't a passive body at all. So what if the models are wrong? What if brightness in this case isn't about reflection or sublimation, but something internal, something self-driven? That's what Avi Loeb hinted at when he spoke of unexplained energy. He said, if there's no gas, then the light must come from within. It's not a metaphor, it's a diagnosis, a suggestion that there might be processes we've never catalogued before. And, the more we test, the more fragile our certainty becomes. The usual comet models rely on equilibrium: sunlight heats the nucleus, ices sublimate, gases scatter light. Simple cause and effect. But for 3I Atlas, there's no gas, no evidence of sublimation, no visible jets. It's like watching a stone glow. You can't explain that with ice. You can't explain that with dust. Some researchers proposed the possibility of a metallic core, reflecting light more efficiently, perhaps coated in crystalline structures that focus and re-radiate sunlight. Others suggested electric currents induced by the solar magnetic field might excite the outer layer, producing a kind of phosphorescent corona. But none of those ideas predict a brightening law as steep as d to the -7.5. None predict color shifts that lean bluer than the sun itself. So, we circle back to the mystery. And it's funny, isn't it, how every time we think we've understood the cosmos, something small, something silent, drifts in from the dark and asks us to start over. 3I Atlas isn't shouting at us. It's whispering, but the whisper carries across centuries of certainty. It's telling us that maybe the laws we love are local, not universal. That the physics of home doesn't always apply to what comes from beyond. You see, that's the quiet revolution here. For centuries, we've built our understanding of comets from the ones born under our own Sunday. But interstellar visitors, they come from elsewhere, from systems that might have formed under different radiation, different chemistry, different magnetic histories. Their matter might remember other stars. Their atoms might be tuned to frequencies unknown to ours. And, maybe that's why. This one behaves as it does, because it was never meant to obey the rules of our sky. Still, scientists cling to their equations. It's what we do. We measure, we compare, we plot, and predict. But here the data laughs at us. The error bars are too small to dismiss, the instruments too precise to doubt. Every frame from stereo A Every coronagraph reading from SOHO and GOES 19 points to the same impossible curve. The brightness shoots upward faster than any known mechanism allows. It's like watching a candle burn brighter the closer it gets to a flame, instead of melting away. And there's something almost tragic in that image. We expect things to fall apart near the Sunday comets disintegrate, ices vaporize, dust scatters. Yet 3I Atlas, instead of dying, came alive. It grew. It bloomed into brilliance where it should have faded. That reversal feels symbolic somehow, a reminder that decay and illumination might not always be opposites. Theories crumble one by one. Reflection fails, outgassing fails, photolysis fails. What remains? We could imagine new physics, non-linear photon scattering, field-driven luminescence, or some exotic reaction between cosmic rays and interstellar minerals. But, well, even those are guesses stitched together with hope. Loeb once said that science progresses through anomalies, and this is an anomaly so pure that it feels almost like a gift. A moment when the universe cracks open just enough to let us peek through. It's uncomfortable, of course. We don't like what we can't explain, but maybe that's the point. When you strip away the equations, what you're left with is wonder. Why should a small body from another star glow like this? Why should its light follow such a strange curve? Why should it defy entropy itself, brightening as it approaches destruction? Perhaps it's because the universe, in its deep indifference, still holds space for beauty that breaks its own rules. And there's another layer, a quiet philosophical one. We often think of science as a ladder climbing toward truth, but maybe it's not a ladder, maybe it's a spiral. Each time we circle back to mystery, we see it from a higher point of view. 3I Atlas is part of that spiral. It's not ending a theory, it's pulling us around to see light and matter from a different angle. That's what makes it so powerful. Because it's not just the data that breaks, it's our imagination that bends. When you see numbers like these, you realize how fragile human understanding really is. We build entire civilizations on what we think is true, and then one blue light from the edge of the stars comes along and reminds us that truth is still moving. So, maybe it's not failure at all. Maybe the collapse of our models is the start of something else, a kind of renewal. When the old explanations crumble, new ones can form, strange and beautiful. 3I Atlas doesn't destroy physics, it widens it. It invites us to dream equations big enough to include the unexpected. And, if we listen carefully, we might hear the echo of Oumuamua in all this, that first interstellar traveler that also defied every rule. It didn't outgas, yet it accelerated. It didn't reflect sunlight the way a rock should. Loeb saw in it a pattern, a possibility, that maybe these are not random exceptions, but signs of a broader phenomenon that interstellar space might send us objects powered by something beyond thermodynamics. So here we are again, at the same threshold between what fits and what doesn't, between what we can prove and what we can only feel. Theories fail, and that failure is fertile. From it grows curiosity, and from curiosity, discovery. And as the light of 3I Atlas continues to climb as it burns blue against the black, the questions begin to multiply. What if it's not just energy we don't understand, but intent? What if the brightening is not a side effect, but a signal? What if the universe, in its silence, has been speaking all along, and we've only now begun to listen? And so, standing before all that uncertainty, one name kept returning: Avi Loeb. He has become, something of a mirror for our collective unease, reflecting the tension between skepticism and imagination. While most astronomers still search for the comfort of conventional physics, Loeb dares to ask the impolite question, what if 3I Atlas is not behaving like a comet because it isn't one? What if, its strange luminosity, its defiance of thermal laws, its blueness brighter than the sun, are not accidents of nature, but hints of design? Not proof, no, but possibility. He's cautious, of course. He doesn't proclaim, he proposes. If there's no outgassing, he said, then perhaps we are witnessing a form of energy not yet understood. That sentence has echoed ever since. It's simple but heavy. It carries both wonder and unease, the feeling that the universe has just whispered a secret and we're not sure whether to believe it. And, well, when Loeb speaks of unexplained energy, he isn't talking about fantasy. He's talking about a pattern, a consistency, a clue repeated in the data. You see, this isn't the first time something like this has happened. Years earlier, another interstellar visitor passed through Oumuamua. It too accelerated as it moved away from the sun, without any visible jets or dust. It too reflected light in ways that didn't match rock, ice, or carbon. Loeb's argument back then was not that it was artificial, but that we should keep our minds open to that possibility, not just for the sake of the unknown, but for the sake of science itself. Because science isn't about protecting what we know, it's about challenging it. And 3i Atlas feels like a continuation of that conversation, a second messenger, carrying the same signature anomaly: motion without mass loss, brightness without gas, color without heat. Two separate objects, two different trajectories, and yet the same defiance. That pattern, it bothers people. Because if coincidence repeats, it stops being coincidence. Loeb calls this a whisper from the cosmos, a sign that the universe might be testing our assumptions. He even hinted, gently, that perhaps 3i Atlas could be a fragment of a larger structure, a thin sheet, a reflective surface designed to harness sunlight. In one interview, he compared it to a solar sail, something built to travel between stars using nothing but radiation pressure. If nature can build it, he said, then so can someone else. It's not a claim of alien life, no. It's an invitation to let curiosity breathe. And, that's what makes Loeb different. Where others see a threat to reputation, he sees an opportunity to expand language, to widen thought. Him, Unexplained, isn't a failure. It's a stage of discovery. The phrase, unexplained energy, isn't meant to mystify, it's meant to dignify our ignorance. It says, here lies something we don't yet understand, and that's all right. But not everyone feels that way. Many of his colleagues criticize him for speculation, for pushing beyond data. They say he's leaping from evidence to narrative. But perhaps that's the point. Every great leap in science begins with a story. Someone imagines what might be true and only later do equations catch up. It was that way with relativity, with quantum theory, with the expansion of the universe. So maybe imagination is the first form of evidence. Still, Loeb grounds his ideas in observation. He doesn't rely on faith, he relies on curiosity disciplined by math. His team analyzed the brightness curve of 3i Atlas across multiple instruments, and the numbers refused to flatten. The ratio between flux and solar, distance held stubbornly at -7.5. If reflection alone can't explain that, then some other mechanism must. And when the simplest explanations fail, he says, we must entertain the extraordinary, not because it's romantic, but because it's necessary. That's what draws me to his work. He doesn't claim to have answers. He claims the right to ask bigger questions. And those questions stretch beyond comets, and light they touch the nature of existence itself. Why should the universe produce order so intricate it can look like intention? Why should an object from another star glow in a way that mimics purpose? Maybe purpose and physics are not opposites, but layers of the same truth. Maybe the cosmos isn't indifferent, it's expressive. There's a humility in that view. Loeb often says that the greatest arrogance in science is assuming we're typical. If we're not alone, he said once, then the universe might already be, communicating not in words, but in phenomena. Perhaps 3i Atlas is one of those phenomena, a form of communication too large for language, too subtle for certainty. And, you can sense how unsettling that is for the scientific establishment. Because if we admit that something might be designed, then we open the door to intelligence beyond Earth, and with it, the fear of meaning. It's easier to study a rock than a message. It's easier to catalogue light than to wonder who sent it. But science, at its heart, isn't about comfort. It's about confrontation, the meeting between what is known and what resists knowing. Loeb's idea of unexplained energy reminds us that the frontier isn't just out there, In distant galaxies, it's right here, in the way we interpret what we see. He often compares it to hearing a sound in the dark. We don't need to call it music to admit that it's there. All we need is the courage to keep listening. You can almost imagine him, late at night, sitting before a wall of images, tiny points of blue, data lines bending in improbable ways, and wondering what kind of power makes something glow from within. He doesn't say alien, he says anomalous. But behind the word lies the thrill of possibility, the feeling that maybe the universe is trying to tell us something. And it's fascinating, isn't it? How history keeps looping back. Oumuamua, 3I Atlas, both forcing us to reconsider the boundary between the natural and the artificial. It's not about fantasy, it's about patterns. When two events share anomalies that no model can explain, we're compelled to look for commonality. Could it be that these objects are part of the same population relics of technology scattered through interstellar space? Or are they natural fragments from systems so alien that our chemistry cannot yet describe them? The truth might be neither, or both. Loeb often says that science, you should not fear ridicule, only stagnation. We are explorers, he wrote, and explorers must walk toward the unknown, not away from it. That might sound romantic, but it's also a reminder that progress demands risk. Every telescope pointed at 3I Atlas is a small act of rebellion against certainty. Every measurement that defies expectation is a step into the dark, and in that darkness, something extraordinary happens. The old definitions of life, intelligence, and design start to blur. If a rock can mimic intent, if a comet can radiate energy without fuel, then maybe intelligence itself isn't confined to biology. Maybe energy can organize itself, structure itself, express itself, not through thought, but through pattern. Maybe what we call design is simply the universe learning to arrange itself in complex ways. That's what Loeb means when he speaks of humility, not that we're small, but that reality is large, so large that even something as faint as a comet's light might hold a lesson about consciousness, about creation, about what it means to exist. It's not faith, it's reverence for data that won't obey. And maybe that's where science and wonder finally meet, not in certainty, but in surrender. The kind of surrender that allows you to say, I don't know, but I want to find out. That's what 3I Atlas demands of us. It asks us to release our grip on the familiar and open ourselves to the unthinkable. As Loeb continues to gather support for deeper observation, preparing for when the object re-emerges from behind the sun, a quiet tension fills the community. Some wait to disprove him, others wait to see if he's right. But everyone, whether they admit it or not, feels the gravity of the moment. Because if 3I Atlas does carry internal energy, if its light comes from within, then it changes not just astrophysics but philosophy. It means that matter itself might be capable of more than the reflection, that the universe might be capable of intention. And perhaps that's the real revelation here. It's not about aliens, not about technology, not even about comets. It's about possibility, about the human need to keep asking when the stars seem to answer. The unexplained energy of 3I Atlas isn't just a scientific puzzle, it's an existential mirror. It reflects our own hunger to understand, our own yearning to see meaning in the void. And as the sun's glare slowly begins to fade, and the blue light of 3I Atlas prepares to return to our telescopes, another thought begins to form, a quieter, deeper one. What if science itself, like this wandering object, burns brighter the closer it comes to the fire of the unknown? What if the next step isn't to explain, but to question better, to look deeper, to practice, as Loeb says, the art of doubt? And so, the story of Avi Loeb isn't really about one scientist at all. It's about what happens when science dares to look itself in the mirror. When Loeb first spoke of unexplained energy, it wasn't a declaration. It was a provocation, a call to remember that knowledge without humility becomes dogma. He knew it would stir the field, and it did. Some called him reckless, others visionary, but perhaps both are necessary. You see, without the courage to doubt, even truth begins to ossify. Well, that's the strange beauty of scientific doubt. It's not a crack in the foundation. It is the foundation. Science doesn't move by faith, it moves by friction, by the rubbing together of certainty and question, And, when that friction generates heat, that's when discovery begins. So, in a way, 3I Atlas is more than a comet. It's a mirror held up to the very process of thinking, showing us that skepticism is not the opposite of belief, but its most honest form. Loeb often says, the universe is under no obligation to make sense to us. And, he means that in the kindest way. It's a reminder that humility isn't defeat. It's a scientific instrument. It sharpens our senses, allows us to see what pride would otherwise hide. And in the case of 3I Atlas, humility might be the only lens strong enough to reveal the truth. Because, really, when everything we know collapses under the weight of a single observation, what else is there but wonder and re-examination? You can almost imagine the tension in research rooms across the world, the screens lit with blue graphs, the faces lit by contradiction. Some scientists trying to fit the data into familiar patterns, others quietly accepting that the patterns themselves might need to change. And that's how progress happens, not through harmony, but through discord that refuses to resolve too soon. It's easy to forget that science was never built to comfort us. It was built to challenge us. Every major leap in human understanding, from the motion of planets to the structure of atoms, began with someone brave enough to say, "What if we're wrong?" So maybe the real power of 3I Atlas isn't in its light, but in what it provokes. It forces us to examine how we think, how we react to mystery. Do we tighten our definitions or widen them? Do we protect our theories or let them evolve? And, it's here that Loeb's role becomes fascinating. He embodies the paradox of a scientist who questions not out of disbelief, but out of devotion to the idea that truth must always be larger than the theories meant to contain it. You see, he doesn't reject the mainstream, he simply asks it to breathe. And that breath, that pause, is where innovation lives. Skepticism, in its purest form, isn't the act of saying no, it's the art of asking how. And 3I Atlas, with its blue glow and impossible brightness, is the perfect canvas for that art. It challenges every assumption about comets, about energy, about what we think the universe should do. It whispers that maybe our rules aren't laws, but local customs of the cosmos, convenient simplifications that fail under the weight of the extraordinary. Loeb's critics accuse him of romanticizing anomalies, but perhaps that's exactly what science needs: a little romance, a little reverence. Because data without wonder is sterile. We need people willing to look at the unexplained and feel awe instead of fear. That feeling, that trembling between knowing and not knowing, is what drives discovery forward. And, that brings us to something deeper, the relationship between skepticism and imagination. We often think they're opposites, but they're partners. Imagination gives us the courage to ask. Skepticism gives us the tools to verify. Together they form the rhythm of discovery, a pulse that beats through centuries of human curiosity. It's the same rhythm that drove Galileo to his telescope, Einstein to his equations, and now, perhaps, Loeb to the light of 3I Atlas. There's a line I keep coming back to. Skepticism is not denial. It's the first step of curiosity. It's so simple, and yet it's everything. Denial says, "This cannot be." Skepticism says, "Show me more." And that's exactly what's happening now. Dozens of teams are reanalyzing data, recalibrating instruments, reviewing solar wind models, even testing for optical interference, not to disprove the phenomenon, but to understand it. To be skeptical is to care enough to look closer. And, that's what makes 3I Atlas so transformative. It's forcing the entire astrophysical community to look closer, not just at the data, but at themselves. To ask, are we still explorers, or have we become archivists of what we already know? The comet, or whatever it is, has become a question aimed straight at the heart of science. Loeb's open-mindedness can feel radical in an age obsessed with certainty. But he reminds us that the greatest discoveries often begin as heresies. Continental drift, quantum mechanics, cosmic inflation, all were once dismissed as speculation. Every truth begins as doubt. And maybe Maybe that's why 3I Atlas arrived when it did, to remind us that we haven't reached the end of the map. You see, when we call something unexplained, we're really describing ourselves, our limits, our blind spots. 3I Atlas doesn't need our permission to exist. It simply is. The only question is whether we're willing to expand our definitions to meet it halfway. Skepticism, then, is not a wall but a door. It doesn't keep mystery out, it lets understanding in. And, if we're honest, we need that door now more than ever, because the deeper we look into the cosmos, the more it reflects us back. Every unanswered question becomes a mirror for our own uncertainty. We see our arrogance, our fear of being wrong, our longing for certainty in a universe that promises none. But through that discomfort comes growth. Through that trembling comes light. Perhaps that's why the best scientists are never quite satisfied. They live in a permanent state of gentle doubt, confident enough to test, humble enough to be surprised. And 3I Atlas has given them plenty to be surprised about. Each new observation is like another note in a song we don't yet know how to hum. The melody is strange, yes, but it's beautiful too. And somewhere in all this, in the clash between belief and question, data and wonder, lies the art of science itself. It's not just a method, it's a temperament. A way of existing in the face of mystery, without collapsing into fear. That's why Loeb's voice matters. Not because he's right, but because he reminds us how to stay curious when the sky turns strange. The story of 3I Atlas isn't over. It's still unfolding in silence and light, and the best minds on Earth are watching, measuring, debating. But underneath all the equations and skepticism runs something more human, the quiet awe that maybe, just maybe, the universe still has surprises left for us. And as those surprises multiply, as new models begin to form and old ones fall away, a new kind of conversation begins, not about what we know, but about how we learn. About how doubt can coexist with faith in the process. About how science, at its most honest, is not the conquest of mystery, but the companionship of it. And, as the light of 3I Atlas continues to shimmer through the sun's glare, that companionship deepens. You can feel it, the sense that something is shifting, that our understanding is being remade, not by certainty, but by wonder, disciplined through reason. The skepticism that once seemed like resistance now feels like reverence. And in that reverence, perhaps, lies the next step toward theories reborn, models reshaped, and waiting just ahead, the first fragile attempts to explain how such impossible light could ever exist at all. And now, as the questions about 3I Atlas began to stack higher than the data itself, the community turned its collective gaze toward the only thing that might bring order to the chaos models. We built them not out of certainty, but out of longing. Because, well, that's what science really is, the act of turning confusion into structure, however fragile that structure might be. So, one by one, theories began to take form, 4 main possibilities, each glowing faintly in the dark, each promising, for a moment, to explain the unexplainable. The first, and perhaps most immediate, was plasma. The idea that, the sun's own breath, that endless flow of charged particles known as the solar wind, might be colliding with the body of 3I Atlas and forcing it to radiate. If the object were conductive, even slightly, it could act like a node in a vast electrical circuit, producing light not from combustion, but from excitation, like an aurora drawn out into space. It was beautiful, elegant even, this notion that the comet was not glowing by its own will, but being played like an instrument by the sun itself. But, the equations strained under their own weight. To sustain a glow that bright, the surrounding plasma density would have to be enormous, hundreds of times greater than anything measured near that orbit. And there were no fluctuations in brightness, no flicker, no telltale magnetic ripples. The light was too smooth, too stable. It was as if the universe had drawn a perfect line, and plasma by its chaotic nature cannot draw such lines. So the second hypothesis emerged. Perhaps it wasn't the space around it, but the surface itself. Maybe, 3I Atlas carried a strange kind of skin, something metallic, reflective, structured at microscopic scales to scatter sunlight directionally. Some even imagined a lattice of thin films, a geometry that amplified blue, wavelengths while damping red. A natural photonic crystal, maybe, or, and here, voices grew quieter, something not entirely natural. The metallic hypothesis had a certain symmetry to it. It could explain the lack of gas, the absence of jets, the sharpness of color. If the object's surface were engineered or simply formed in a star system richer in metals, it might reflect light unlike anything we've seen before. The problem, though, is that reflective materials do not brighten exponentially as they approach the sun. They saturate. And yet, 3I Atlas did not saturate. It blazed higher, deeper, the blue pushing beyond expectation, until instruments began to clip at the edges. That led to the third idea, electromagnetic induction. The thought that 3I Atlas, moving rapidly through the sun's magnetic field, might act as a generator. As it cut across magnetic lines, currents could form, producing energy inside the object itself. This would mean that the light was not reflected, but emitted a self-sustaining dance of motion and magnetism. And, it sounded promising. After all, the physics of induction is simple. Motion through a field creates flow. Flow creates heat. Heat creates light. But the beauty of simplicity often hides its limits. For induction to work at such intensity, the internal structure of 3I Atlas would have to be extraordinary, not a loose assembly of dust and ice, but something dense, conductive, resilient, something that could carry immense currents without vaporizing. And, well, nothing we know of in the natural cosmos behaves that way. Every comet we've studied has been fragile, volatile, a snowball with delusions of grandeur. This one, however, behaved like a machine. So we turned inward again, looking deeper, to chemistry and decay, the fourth and final hypothesis. Perhaps the blue light was not electromagnetic, not reflective, but chemical. Maybe the object contained rare isotopes, slowly, breaking down, releasing bursts of photon energy as they decayed. Or, perhaps, volatile compounds exposed to sunlight reacted in new, unknown ways. There are materials, after all, that glow under radiation, minerals that trap energy and release it in luminous waves. Could this be one of those, magnified on a cosmic scale? But again, the data refused to play along. The spectral profile of 3I Atlas was clean, almost too clean, narrow, consistent, showing none of the complexity that chemical reactions leave behind. It wasn't messy enough. It was, disciplined light, controlled, continuous, pure. It felt, and I hesitate to use the word deliberate. And yet, perhaps that's what makes this so haunting. Each model, each hypothesis, seems to explain something, but not everything. Plasma explains the glow, but not the stability. Reflection explains the color, but not the intensity. Induction explains the mechanism, but not the material. Chemistry explains the persistence, but not the purity. Each is a window into truth, and yet the view never quite aligns. Still, each theory matters. Each adds a layer to our understanding of what could be happening. Plasma reminds us that the sun is a living force, that space itself is electric. Reflection shows us how structure can manipulate light. Induction reveals the hidden marriage between motion and magnetism. And decay teaches us that even in death, matter can shine. These aren't just theories about a comet, they're metaphors for us. We too are trying to hold our brightness against the pull of entropy. And, perhaps that's why scientists keep returning to this mystery. It's not just curiosity, it's empathy. We see something that refuses to fade, and we want to know how. We, who are temporary, want to learn from something that seems eternal. 3I Atlas has become a lesson in resilience written in light. But there's another layer too, the emotional one, the human one. These models, for all their math and logic, are really stories we tell ourselves. Each hypothesis is a way of saying, the universe still makes sense, even when it doesn't. We need that sense of order, we crave it. Because if 3I Atlas truly defies all explanation, then the boundary between nature and the unknown grows frighteningly thin. Loeb once said that the difference between science and mythology is only that science updates its stories with better data. And maybe, that's what we're doing now. updating, evolving, building myths that can hold more truth. Whether 3i Atlas is a plasma beacon, a metallic sculpture, a magnetic generator, or a glowing relic of interstellar chemistry, each possibility, however imperfect, brings us closer to awe. And, that awe is essential. Without it, science collapses into arithmetic. The equations must breathe. They must leave room for astonishment. Because, really, what else are we doing if not learning how to be astonished more accurately? So here we are, holding 4 imperfect keys to a single, locked door. None fit cleanly. Each turns a little, catches, but stops just short of opening. Yet somehow, that's enough. Because the act of trying, the reaching, the imagining is what science is. And 3i Atlas, in its silent brilliance, keeps the lock shining, waiting for us to try again. The models will grow, the data will deepen. New spectra will come from Hubble, from JWST, from instruments designed to pierce the veil of infrared. They may confirm one hypothesis, or shatter all 4. But until then, we hover in this beautiful tension, not knowing, but not lost, suspended between what we can measure and what we can only feel. And, somewhere in that balance, in that fragile uncertainty, lies the heart of this mystery. The promise that the next observation might not just refine our theories, but rewrite them. Because soon, when 3i Atlas emerges once more into view, when the great telescopes of Earth turn toward it again, the universe will hand us new numbers, new colors, new questions. And with those questions, the story will shift from what it might be to what it will reveal. And so now, as the models stretch and bend under their own uncertainty, the world waits, eyes turned upward, telescopes cooling in the long quiet before their next awakening. Because soon, in December of 2025, 3i Atlas will reappear. It will drift out from behind the sun, back into the line of sight, and once again, the light of that strange interstellar traveler will fall upon our instruments, our screens, our waiting minds. You can almost feel the tension in the air, that delicate hum between knowledge and anticipation. And, there's something beautiful about that. We've been living for months in the echo of its brightness, trying to describe a color that no one can see anymore. Now, the universe is offering us a second look. Well, this time, the view will be sharper. The Hubble Space Telescope and the James Webb Space Telescope are already scheduled to point toward the region where 3i Atlas will emerge. Their instruments sensitive enough to detect the faintest whispers of infrared radiation might finally reveal whether the light we saw came from within or without. If the glow truly originates in the core, if there's energy radiating from deep beneath its surface, it will show up there, in the quiet red wavelengths that the human eye cannot see, but the cosmos never stops speaking in. And, well, that's what excites people like Avi Loeb the most. Because you see, optical light can deceive reflection, scattering, lensing, all can mimic brightness. But infrared, that's different. Infrared tells you about heat, about processes that can't hide behind illusion. It's the wavelength of truth, the signature of what's really happening inside. So, when those first images come in, when Hubble captures the return and Webb traces its thermal spectrum, we might, for the first time, glimpse the real source of the unexplained energy. There's a strange poetry to it, isn't there? We've been watching light that may not even belong to sunlight, and now we're preparing to listen for warmth instead. It's like learning a new sense. And, that's what astronomy often is, extending the body of humanity outward, nerve by nerve, into the dark. Across the globe, observatories are being recalibrated. Atacama, Mauna Kea, the Canary Islands, all waiting for the right moment when the blue ghost of 3i Atlas rises again above the horizon. The timing will be critical. For a few weeks in late December, Earth and the object will align just enough for telescopes to catch its reflected glow in the twilight sky. By then, it will be near its closest approach, still tens of millions of kilometers away, but in cosmic terms, that's a whisper. And, if its brightness continues to increase as predicted, even amateur telescopes might detect it as a faint electric spark against the stars. Scientists have already prepared a symphony of instruments. The European Southern Observatory plans to capture polarization data, how the light twists and bends as it moves through space. NASA's SOHO will continue tracking solar wind conditions, searching for correlations between bursts of solar particles and the object's changes in intensity. The Webb telescope, working in the deep infrared, will attempt to detect any excess heat radiating from the core. And, that's the key. If there's heat, there's process. And if there's process, then there's physics we haven't yet mapped. But it's not just about instruments, it's about people, the thousands of minds connected through that shared act of waiting. The graduate students tuning algorithms at 3 in the morning, the astronomers comparing spectra pixel by pixel, the engineers watching telemetry, scroll like heartbeat rhythms across a screen. We sometimes forget that science isn't cold, it's a collective act of wonder disguised as measurement. When the data starts flowing in, it won't arrive as revelation, it will come as noise, numbers, coordinates, intensities, ratios. The miracle isn't in the discovery itself, but in the patience to hear meaning within the noise. That's how truth enters the world, not as thunder, but as pattern. And 3i Atlas, might be one of those patterns, waiting for us to listen closely enough to hear what it's been trying to say since it crossed into our solar system. Well, what's striking is how this object has become more than a scientific question. It's almost an emotional one now. Every few decades, astronomy gives us a visitor like this, something that reminds us that our system isn't isolated, that the universe is still in motion, still sending emissaries from the far reaches of other suns. Oumuamua was the first. It came and went, like a question mark, slipping past before we could turn all our instruments toward it. But 3i Atlas, it lingers. It gives us a second chance to test, to learn, to be humbled again. And, perhaps that's why there's such urgency in this new round of observations. Not fear of missing data, but fear of missing meaning. Because if we can catch the exact moment when the glow peaks, if we can map how it fades or transforms as it moves away, we might learn whether it obeys our physics or invents its own. That's not just curiosity, that's history. Already, preliminary models predict that if the brightening curve continues, as before, the object will emerge from perihelion brighter than when it entered. Think about that for a moment. Most comets are torn apart by the sun's gravity, stripped of their substance, reduced to dust. But this one, this wandering fragment of another world, seems to thrive under pressure. The closer it comes to the fire, the more radiant it becomes. There's a metaphor there, somewhere, one that humankind has always understood in its bones. The Hubble team plans to capture time-lapse imaging of the object across several days, watching for subtle changes in its halo. Any expansion or asymmetry might reveal hidden activity, not jets or gas, but perhaps electromagnetic flows, or surface oscillations, or something entirely unexpected. And the Webb, with its mirrors cooled to near absolute zero, will look for spectral lines that shouldn't exist, the fingerprints of unknown interactions. It's possible, that the glow we see is neither reflection nor emission in the traditional sense, but a kind of hybrid, a resonance between sunlight and matter we've never seen before. In the control rooms, that idea alone is enough to keep people awake. You can imagine the quiet, the hum of air conditioning, the blinking of monitors. Somewhere, a physicist stares at a plot, a small rise in a curve, and imperit, anomaly that might mean everything or nothing, and feels a pulse of awe, because maybe that tiny line, that fractional deviation, is where the universe is trying to reveal something new. And, what's extraordinary is how this single, silent traveler has drawn together so many disciplines. Plasma physicists, materials scientists, quantum theorists, even philosophers, all speaking the same language of uncertainty. It's rare, to find a mystery that crosses so many borders. It's not just astrophysics anymore. It's the study of possibility itself. Loeb once said that interstellar objects are like letters dropped into our cosmic mailbox messages, written not in words, but in light. We just need to learn how to read them. Perhaps, 3i Atlas is such a letter. Perhaps the blue we see isn't just light, it's language. a form of expression we haven't yet learned to translate. And, well, even if that's not true, even if it turns out to be a purely natural process, it will still be miraculous. Because it will mean that nature, in her infinite variations, has found yet another way to create beauty, to make the cold glow, the silent sing, the impossible real. That's what science at its best reveals, not certainty, but astonishment. So as the instruments prepare, as the world waits for December skies to clear, there's a quiet sense of reverence. Somewhere between hope and humility. We don't know what we'll find. We rarely do. But every photon that falls onto those mirrors will carry with it a fragment of the answer, a whisper from a place beyond imagining. And perhaps, when those photons are finally decoded, when the lines of data form an image, when the first spectral peaks reveal what lies beneath the blue, we'll realize that what we've been studying all along isn't just an interstellar object. It's the act of discovery itself. It's us, reflected in the light of something ancient and unknown, reminding us, that the next revelation is never final. It's only the next step toward wonder. And somewhere beyond that wonder, just beyond the reach of these telescopes, another story begins to take shape about where this traveler came from and what it might be carrying within its silent heart. And so, as the world readied its instruments and minds for the return of 3I Atlas, something softer began to unfold beneath the calculations, a kind of quiet reflection, the realization that perhaps, in all our measuring, we had forgotten to ask what this visitor really means. Because every interstellar object is more than matter. It's memory, a fragment of another sun's story, carrying within it traces of light and time older than the Earth itself. And when one of them, crosses our path, it's as if the universe has slipped us a note, brief, cryptic, but deeply personal. 3I Atlas isn't just a comet. It's a reminder that the universe doesn't end at the edge of our understanding. It stretches on endlessly, silently, and, sometimes it sends us things to prove it. When it first appeared, it was small, almost invisible, just a point in the dark. But then it grew brighter, bluer, stranger, as if revealing, step by step, that even a single stone from beyond can carry more mystery than all our models combined. And, perhaps that's the real gift of these interstellar wanderers. They break the illusion of isolation. They tell us that our solar system is not an island. It breathes, it connects, it receives. Every visitor like this, Oumuamua before, Atlas now, is a crossing of worlds, a handshake between distant suns, and each handshake leaves behind a trace of wonder. Astronomers like Loeb have said that interstellar objects are the letters of the cosmos, fragments of communication written in the oldest language there is: motion. You see, when a thing travels between stars, it carries more than rock and ice. It carries a record of physics itself, a signature of how energy behaves in different corners of the galaxy. Each one tells us something about the environments that built it, about the ways matter can organize itself under pressures and temperatures we've never seen here. And that, is why 3I Atlas feels so important, not just as a puzzle, but as a messenger. Its anomalies, the blue light, the brightness, the impossible energy may be its way of showing us that the universe still has rules we haven't learned. It's humbling, really. We tend to think of our science as a lens that sharpens reality, but maybe it's more like a window still fogged at the edges. 3I Atlas wipes a small circle clear. Well, if you think about it, each discovery in astronomy follows the same rhythm. First comes the shock, something that doesn't fit. Then the fear, maybe we were wrong. Then, finally, the beauty, the realization that wrongness is not failure, but invitation. The universe doesn't punish us for misunderstanding. It rewards us with deeper mystery. And 3I Atlas, is part of that tradition. A cosmic teacher that asks its questions not in words, but in wavelengths. Some scientists say it's too early to call it anything special. Others, quietly, admit they've never seen anything like it. Both views are right, because that's what wonder does. It divides us and unites us all at once. It pushes some to caution, others to dream, and between those two poles, the truth slowly takes shape. There's something profoundly human about our fascination with visitors from beyond. We project ourselves onto them, our hopes, our fears, our longing for contact. When a rock from another star system flares blue near our sun, we don't just see physics, we see story. We imagine its birthplace, the star that once held it in orbit, the slow violence that cast it out into the dark. For millions, maybe billions of years, it travelled not lost, just waiting. Until one day, it found us. And, perhaps that's the part that moves me the most, the patience of it. The idea that something could wander for eons only to become meaningful in the brief instant when it meets our eyes. It's a kind of cosmic poetry. We measure it in seconds, but it carries the weight of millennia. So what can we learn from that? Maybe it's that discovery is not about possession. It's about participation. We don't own these moments of revelation. We share them. They're fleeting like comet tails, like breath in the cold. 3i Atlas will leave, and we'll be left with its light. And in that light, well, we might glimpse not just a distant world, but something of ourselves, our own hunger to understand, our own restless movement through time. Every new observation adds a page to that story. The data coming in now, from Hubble, from Webb, from observatories on Earth, will soon form a kind of biography, a record of how this visitor lived near our star, how it behaved under pressure, how it changed, and how it did not. But beyond the technical, beyond the physics, there's another record being written inside us. The way we respond to mystery says as much about humanity as the object itself. Avi Loeb once said, "The universe doesn't owe us meaning, but it offers us beauty." And, maybe that's enough. Maybe beauty is meaning, when you look closely enough. Because to find beauty in something you can't explain, that's the beginning of wisdom. It means you've learned to see without needing to control. And the more we look, the more we realize how interconnected everything is. Every particle that makes up 3i Atlas, every atom of iron or carbon or oxygen, was once part of a star. Some other star, far away, long dead now, but still whispering through this traveller. Its light, the light we chase through our telescopes, is really the echo of a long-vanished sun. So, when we watch 3i Atlas, we're not just observing a visitor, we're remembering a history written in starlight. There's a humility in that. It reminds us that we too are travellers bound to a star, yes, but not fixed. Our own atoms were forged in places just as distant, just as ancient. We are, quite literally, made of interstellar debris. 3i Atlas isn't foreign, it's family. It's a relative we've only just met, bringing stories from home we've long forgotten how to tell. And that's the quiet truth hidden inside all this data. Every time we study the cosmos, we're really studying ourselves, our origins, our limits, our capacity for awe. The object is out there, yes, but the experience, the wonder, it's in here. Inside, the small, flickering consciousness that dares to call itself aware. As the nights of December approach and the telescopes prepare, humanity stands again at the edge of knowledge, not with certainty, but with curiosity. The same curiosity that lit the first fires, that built the first lenses, that sent metal and glass into orbit just to capture a fleeting glow. That's who we are. The ones who can't look away. And, maybe that's what 3i Atlas came to remind us. That exploration isn't about finding answers, it's about keeping the questions alive. Each comet, each beam of light, each unexpected colour, they're all invitations to continue, to move forward, to wonder harder. The cosmos doesn't need us, but somehow it keeps giving us reasons to exist. So, as the faint blue traveller makes its slow departure, we are left with more than images or spectra. We are left with perspective, that our knowing is small, but our seeking that's infinite. 3i Atlas is proof that even the coldest fragment of rock can carry warmth if you know how to look at it. And as it fades into distance once more, its message lingers, soft but unbroken, that we are, all of us, part of something vast, something still unfolding. And somewhere out there, beyond the reach of our current instruments, another traveller is already on its way, carrying the next question, the next spark of light. When the light of 3i Atlas finally began to fade into the dusk of memory, something unexpected happened, not in the sky, but in us. The debates grew quieter, the models more uncertain, and yet what lingered was not confusion, but reflection. You see, the mystery had begun to move beyond the realm of physics, slipping softly into the language of philosophy. Because the question was no longer only how this interstellar visitor glowed, it was why its glow mattered. And that changed everything. Well, we often imagine science and philosophy as separate rooms, one lit by data, the other by doubt. But 3i Atlas walked between them, carrying a kind of light that neither discipline could fully claim. It reminded us that discovery isn't just about new information, it's about the transformation of perspective. When a comet defies every rule you thought you knew, it doesn't just challenge equations, it challenges meaning itself. And, perhaps that's the truest legacy of this object. It forced scientists hard-nosed, methodical, skeptical to face a deeply human question. What does it mean when reality refuses to fit the frame we've built for it? What happens when observation becomes poetry again? When the universe stops being a mechanism and starts becoming a conversation? You see, in the centuries since Galileo first turned his telescope skyward, science has slowly learned to strip wonder from its vocabulary, to trade awe for accuracy, mystery for measurement. And yet, every once in a while, something like this arrives to remind us that those two things were never opposites. Wonder is not the absence of understanding, it's the beginning of it. 3i Atlas didn't destroy science, it purified it. It reminded us that the drive to know is sacred precisely because it begins in not knowing. Loeb himself, spoke about this during one of his lectures. He said, "The danger is not in ignorance, but in certainty." He meant that when we convince ourselves that the map is complete, we stop looking for the uncharted. And this comet, this luminous enigma from another star, tore a hole right through that map. It said, gently but firmly, "Your models are local, your confidence temporary, your universe still larger than your words." It's not that 3i Atlas made science obsolete. No, it made it honest again. Because in its light, we were reminded that science isn't the opposite of philosophy, it's the physical expression of it. Every equation is a kind of prayer, every observation, an act of faith that the universe can be known. But, faith is not the same as certainty. Faith lives with uncertainty. That's what makes it beautiful. And there's something poetic in how this happened. The object didn't roar across the sky with noise or violence. It whispered in color. Its message was subtle, slow, unfolding in blue like an idea dawning. We wanted explanation, but it offered invitation. We wanted control, but it gave us humility. It's almost as if, in that shimmering contradiction, we could hear the cosmos reminding us, truth isn't conquered, it's courted. So what happens next? Once the instruments go silent, once the papers are published, once the theories fall into libraries, what remains? Perhaps the deeper question is not about 3i Atlas at all, but about us. What does it reveal about our nature that we chase the inexplicable? Why do we feel a kind of longing when something resists explanation? Maybe because, deep down, we sense that the unknown is where we belong. That to live in a universe completely explained would be to live in one completely closed. And that's the strange paradox, isn't it? We seek knowledge to banish mystery, yet we need mystery to make knowledge meaningful. It's not the answers that move us, it's the questions. We climb the mountain, not for the view at the top, but for the ascent itself. And 3i Atlas, in its quiet defiance, has given us a new mountain to climb, one made of light and doubt and possibility. Well, when people speak of unexplained energy, it's easy to think of it as something external, a physical process waiting for description, but maybe it's also internal. Maybe that phrase describes us too, beings made of unexplained energy, drawn irresistibly toward the unknown. It's not just the comet that burns blue against the dark, it's our curiosity. It's our desire to make sense of things that won't stay still long enough to be measured. And, maybe that's what makes the line between science and philosophy so thin. They're both, at their core, acts of wonder shaped by discipline. Both are ways of staring into the abyss and choosing not to look away. The physicist and the philosopher, the astronomer and the poet, they're all, in the end, doing the same thing, holding up a fragile flame against an infinite night. I suppose what Three-Eye Atlas teaches us then is not that the universe is unknowable, but that it's inexhaustible. Knowledge doesn't end mystery, it deepens it. Every explanation opens into another question. Every discovery reveals the edge of another frontier. So, when Loeb said that unexplained energy might be something beyond our understanding, maybe he wasn't just talking about photons and heat. Maybe he was talking about wonder itself, the inexhaustible energy of not knowing. It's not the first time this has happened, of course. History is full of moments when data and philosophy collided, when science brushed against the ineffable. The first detection of gravitational waves, the first image of a black hole, the discovery that neutrinos can slip through matter like ghosts. Each of those moments forced us to look again, to question what it means to perceive, to measure, to exist. Three-Eye Atlas stands in that lineage, a reminder that every boundary between the measurable and the meaningful is temporary, and, that's what makes this moment so precious. Because whether Three-Eye Atlas turns out to be a natural phenomenon or something stranger, it has already done something profound. It has made us think again about what science is for. Not just the accumulation of facts, but the cultivation of wonder, not just control of nature, but communion with it. You see, when we look at something that refuses explanation, we're really looking at ourselves at the limits of our understanding and the beauty of those limits. We're reminded that intelligence is not dominance, it's dialogue. The universe doesn't need us to solve it. It invites us to listen. And, well, maybe that's the lesson that will outlast the data. That mystery is not an obstacle, but a relationship. We don't need to conquer it, we need to keep it alive. Because the moment we think we've answered everything, we've stopped asking the only question that matters. What else could this be? Loeb's words, simple as they were, continue to echo. If there's no outgassing, then we may be witnessing a form of energy not yet understood. But maybe, that statement isn't confined to the comet at all. Maybe it's about us the way we, too, radiate energy we don't yet understand. Our curiosity, our empathy, our sense of wonder, these are forms of energy that defy explanation, but define us all the same. So as Three-Eye Atlas drifts farther into the dark, leaving behind its blue trail of questions, we're left to face a softer kind of truth, that every scientific mystery is also a philosophical one. It's not just about what the universe is, but about who we become when we try to understand it. It's not out there, it's in here. The frontier isn't only in the sky, it's in the human mind, still learning how to see. And perhaps, as the data continues to trickle in, as the arguments quiet into contemplation, another realization will dawn that maybe the greatest discoveries are not found in telescopes or equations, but in the space between awe and reason, the space where light becomes meaning and meaning becomes light. And somewhere, in that vast and silent space, another thought begins to take shape about what happens when science no longer looks for control, but for communion. And, perhaps this is the most humbling part, realizing that the universe itself is not just an object of study, but a living laboratory, constantly conducting experiments that we can only witness from afar. You see, every now and then, something like Three-Eye Atlas drifts into view and performs a kind of cosmic demonstration. It takes the laws of physics, the ones we've written so carefully in our books, and bends them, just slightly, in front of us. It's not a rebellion, it's a reminder that the laws we know are only local truths, shaped by our tiny corner of existence. And when something comes from beyond that corner, from another star, another gravity, another chemistry, it's like a message written in a dialect we've never heard before. Well, Three-Eye Atlas has become that message, a messenger from deep time and deeper distance, arriving not to refute our science, but to expand it. Because what if just imagine the same physical laws hold everywhere, but their outcomes vary in ways we've never tested? What if matter itself behaves differently when born in another stellar nursery, when shaped by magnetic fields far stronger than our sun's, or cooled in the shadow of a dying red giant? Three-Eye Atlas, in its glow, might be the first real sample of such matter we've seen, not just a visitor, but a witness to how diverse the universe's laboratory can be. And, that's the beauty of this kind of discovery. It transforms the abstract into the tangible. For centuries, we've modeled cosmic processes on paper: nuclear fusion, dark energy, plasma dynamics. But objects like this are real tests. They are experiments the universe has already run, and now, slowly, we are catching up to the results. 3. I-Atlas, by simply existing, is a data point that could rewrite the boundaries of what matter can do. Some physicists have started to whisper quietly, cautiously, that maybe the object's behavior isn't just about energy, but about structure. That perhaps, 3 I-Atlas contains matter arranged in a configuration unknown to us, a lattice that stores and releases energy in ways unlike anything we've seen. It's not impossible. Quantum materials, even on Earth, behave unpredictably when cooled or magnetized in extreme ways. Scale that up to the interstellar, and who knows what kind of complexity might emerge. You see, we often think of the universe as static, ruled by constants. But constants, are only constant where we've measured them. What if there are pockets, regions, or epochs where the values shift slightly, subtly, giving birth to new interactions? What if energy can pool or resonate in ways that look, from our limited perspective, like anomalies? Maybe that's what 3i Atlas is showing us. Not magic, but variance. The physics of elsewhere. And, perhaps that's why Loeb and others are so fascinated. Because when you start to see the cosmos as a living laboratory, you stop treating anomalies as mistakes. You start treating them as clues. Each one, a footnote from nature, saying, there is more here than you've accounted for. That's how progress begins, not by confirming what we already know, but by encountering what we don't yet understand and refusing to look away. So maybe the real question isn't whether 3i Atlas is natural or artificial, ordinary or alien. Maybe the real question is what kind of physics it's inviting us to explore. If the object truly emitted energy in a way that defies thermal models, then we are looking at a mechanism that converts one form of motion, orbital, magnetic, or quantum, into light without heat. That alone would be revolutionary. It could reveal processes at work in the interstellar medium, perhaps even connected to the elusive phenomenon we call dark energy, the strange pressure that drives the expansion of the universe. Well, to think that such vast concepts could be tested by a single traveler of ice and dust, that's astonishing. But, that's the nature of science in the cosmic scale. The smallest object can reveal the grandest truths. Every comet, every asteroid, every interstellar rock is a probe sent by the universe itself, unbidden, unplanned, carrying data across eons. They are not ours, but they are for us if we're paying attention. Some scientists now argue that studying interstellar visitors could become a new field entirely, a laboratory of cosmic material science. Instead of waiting for them to pass by, we could learn to intercept them, to sample them, to see what atoms look like when forged beyond the solar cradle. Perhaps one day, probes will rendezvous with such travelers mid-journey, collecting their chemistry, their magnetic signatures, their histories encoded in isotopic layers. That, would turn every anomaly into a classroom. And perhaps, deeper still, it would change our relationship to the universe itself. Because once you begin to see space as alive with experiment, once you see every star system as a different trial, every comet as a data point, you realize that the universe isn't indifferent. It's expressive. It's telling us about itself, constantly, through the language of phenomena. And we, in turn, are learning to listen. It's not, an easy kind of listening. It requires patience, humility, and the willingness to admit that what we find may overturn our most cherished truths. But that's, the essence of discovery. To test your understanding not in comfort, but in contact with what refuses to fit. 3. I-Atlas challenges us to treat the cosmos not as a museum, but as a dynamic field of ongoing experiment. Every star's magnetic field, every orbiting planet, every collision between ice and light, all of it is data in motion. The universe is not a set of finished laws, but an unfolding process of laws interacting. It's not static, it's symphonic. And that realization, that slow dawning, brings us closer to something profound. Because if the universe is a living laboratory, then we are not outsiders studying it from afar. We are participants. Every observation we make, every question we ask, alters our understanding, reshapes our consciousness, and thus changes the universe in a small reciprocal way. The act of looking becomes an act of participation. Well, that's the strange beauty of it, isn't it? The deeper we study the cosmos, the more it seems to study us back. The boundary between observer and observed begins to blur. Maybe that's what this glowing traveler came to teach, that the laboratory and the experimenter are one. And, perhaps that's why the blue light of 3i Atlas feels so haunting. Because it wasn't just physics we were seeing, it was dialogue, between matter and mind, between the known and the unknown, between human curiosity and cosmic creativity. That's why it stays with us, long after the light fades, not as a mystery to be solved, but as a relationship to be tended. And as new instruments prepare for future visitors, as next-generation telescopes and probes begin their long orbits around the Sun, we start to see the pattern. These encounters are not accidents. They are invitations to learn, to question, to join the ongoing experiment that is the universe itself. So, maybe the real experiment now isn't happening out there at all. Maybe it's happening in here, in how we respond to wonder, in how we handle the unknown. The cosmos is vast enough to hold both matter and meaning, and we, small as we are, stand at the intersection of the two, trying to listen as the universe whispers its next hypothesis. And somewhere, in the stillness after the light of 3i Atlas fades, another silence begins to form, not the silence of absence, but of anticipation, as the telescopes turn again toward the darkness, waiting for the next distant signal to rise. And now, as the instruments fall silent again, as the telescopes rest in their domes beneath cold morning skies, what remains is the echo of something vast and unspoken that 3i Atlas left behind. You can almost feel it, that hum of unfinished thought that lingers when an experiment ends, but the meaning hasn't quite settled. The light has faded, yes, but, its presence has not. It's there in the data, in the dreams of the scientists still poring over those long columns of numbers, and in the quiet, private wonder of anyone who once looked up and saw, however faintly, that impossible blue. Well, you see, this is the moment that always follows discovery, the reckoning, the silence after the noise, the pause when knowledge begins to turn into understanding. And that, perhaps, is the hardest part, because data gives us answers, but meaning requires reflection. What 3i Atlas truly revealed wasn't just about comets or interstellar matter, it was about us, and about the strange, luminous relationship we share with the unknown. We watched it, we measured it, we argued about it, but, in doing so, we also became part of its story. We turned it from an object into an idea, from a thing drifting through darkness into a mirror held up to our own curiosity. And that's the quiet miracle of science, isn't it? That in trying to explain the universe, we end up explaining ourselves. And, well, maybe that's what we've been doing all along, building instruments not just to see the stars, but to hear the sound of our own questions echoed back. Every telescope, every equation, every late-night debate over a glass of coffee or wine, they're all the same act of faith. Faith that the universe is listening. Faith that it will answer, even if the answer comes in a language we don't yet understand. When 3i Atlas passed through Perihelion, when it burned bluer and brighter than the sun, the instruments saw photons. But we saw something else, something almost emotional. It wasn't just light, it was revelation. It was the feeling that the universe still has surprises left, that it still has new ways to astonish us. And maybe, that's what it was trying to show, that surprise itself is part of the design. Avi Loeb, in one of his quieter moments, said, "The universe is not obligated to be simple. We are obligated to keep wondering." And, those words stayed with me, because that's the line between knowledge and wisdom, the willingness to keep wondering. The courage to admit that every answer is temporary, that even our most elegant theories are just bridges built across uncertainty. And yet, despite all our limits, there's something magnificent in the attempt. The act of looking outward, of turning eyes and minds toward the cosmos, is an act of defiance against meaninglessness. It's us saying, softly but persistently, we are here. We are trying. Every photon we capture is a message, returned, proof that the dialogue continues. Maybe that's what the light of Three-Eye Atlas really was. Not a puzzle to be solved, but a conversation to be continued. A spark between two forms of awareness, one vast and ancient, one young and curious. We like to think of it as an object, but perhaps it was an interaction, a brief alignment between the universe's expression and our ability to perceive it. And the more I think about it, the more it feels like a kind of cosmic symmetry. The universe gives us anomalies, and we give it attention. The universe gives us uncertainty, and we give it curiosity. It's not a one-way process. It's not the stars performing for us. It's collaboration, the oldest and most beautiful form of communication. Well, that collaboration changes us. It has to. Every discovery leaves a trace, not just in textbooks but in our very sense of self. The people who saw the first images of Three-Eye Atlas, who watched the blue shimmer grow and fade, they won't think of the universe in quite the same way again. They've glimpsed something that refuses to fit, and that refusal becomes a kind of doorway, a doorway into new ways of seeing. And, maybe that's the quiet truth about the unknown. It's not a wall, it's an invitation. It looks like a boundary, but it's really a horizon. We approach it thinking we'll find limits, and instead, we find depth. We find that the universe is not a place to be mapped, but a relationship to be deepened. You know, when you think about it long enough, Three-Eye Atlas becomes more than an interstellar visitor. It becomes a teacher. It teaches patience because understanding takes time. It teaches humility because even our greatest instruments can't yet touch its essence. And it teaches reverence because sometimes the right response to the unknown isn't to dissect it, but to listen to it, to let it speak in its own slow cosmic way. And, perhaps that's the direction science must move toward now. Not just the pursuit of control, but the cultivation of empathy with the universe. We don't need to dominate the cosmos to understand it. We need to listen, to watch, to allow wonder to coexist with analysis. Because it's not just about explaining how things work, it's about learning how to belong among them. Loeb often speaks about this, too, how discovery should never become conquest. He says, curiosity is the gentlest form of courage. And maybe that's what Three-Eye Atlas has inspired, a new kind of courage. The courage to wonder without ownership, to study without assumption, to stand before the unknown and let it remake you. You see, the universe doesn't reward arrogance. It rewards attention. It rewards sincerity. And Three-Eye Atlas, quiet, beautiful, impossible, is the kind of phenomenon that demands both. It asks us not to solve it, but to learn how to see differently, to stretch the limits of imagination until they become indistinguishable from science. And so, perhaps, this is the new frontier, not just outer space, but inner space, the space of perception, of consciousness, of meaning. The cosmos is vast, yes, but it's also intimate. It's in the way we feel small when we look up, the way silence deepens when we think of light years, the way mystery can make us, both terrified and grateful at once. It's not out there, it's in here. The frontier is not a distance, it's a perspective. And maybe that's the most profound revelation of all, that the act of observing the universe is, in itself, an act of connection. When we study a comet, we study the memory of stars. When we trace its orbit, we trace the path of energy that has been moving since before we were born. And when we watch it disappear, we witness the rhythm of creation and return the same rhythm that pulses through our own lives. So perhaps Three-Eye Atlas was never really leaving. Perhaps it's still with us, in every question it left unanswered, in the silence between facts, in the subtle change it made to the way we think about light, about energy, about existence itself. The object may drift away, but the idea remains, glowing quietly at the edge of comprehension. And, Somewhere in that fading glow lies the promise of something greater, the realization that the universe doesn't just contain meaning, it is meaning. Every star, every atom, every wandering fragment of matter participates in that vast unfolding conversation. And we, the listeners, are part of it too. Perhaps that's where the story turns next, into a deeper kind of listening. Into the search not only for what the universe is made of, but what it's trying to say. And so, when the light of Three-Eye Atlas turned from spectacle to silence, when it slipped once more into the cold anonymity of space, the question that lingered was not what was it, but what did it ask of us? Because, well, every time we look into the universe and find something we cannot name, we are not simply discovering a phenomenon, we are discovering a question, one that keeps unfolding the more we try to answer it. Three-Eye Atlas, in all its impossible blue, became that kind of question. It wasn't an object anymore. It was a mirror, a slow-burning riddle, reflecting the very nature of inquiry itself. You see, the closer scientists looked, the less the comet revealed, or perhaps the more it revealed about our limits. The data, remained stubbornly ambiguous. No outgassing, no jets, no clear signature of dust or molecules, only light, pure, consistent, inexplicable light. It seemed to burn by its own design, following laws we only partially understood. And that unsettled everyone, because the deeper you study something like that, the more you start to realize that maybe explanation itself is not the point. Maybe some things exist to stretch our idea of what can be explained. Well, that's the paradox of discovery, isn't it? The closer we come to knowing, the more we are reminded that knowledge is infinite, that each answer breeds new mysteries. The blue of Three-Eye Atlas, that strange defiance of thermodynamics, wasn't just a puzzle for astrophysics, it was a challenge to our imagination. Because to imagine something outside the framework of what we already believe possible, that's the true act of science. Avi Loeb once wrote that the greatest form of humility is curiosity. And, that feels truer now than ever. The humility to admit that perhaps the universe does not behave according to our expectations, and the curiosity to keep watching anyway. It's that dual motion to doubt and to wonder at the same time that defines what it means to be human in the face of the cosmic unknown. As the data continue to pour in from Hubble, from Webb, from the ground-based observatories scattered across the Earth, the models fractured into possibilities: plasma, metallic reflection, induction, decay none complete, all provisional. It was as if nature were saying, look again, look deeper. And maybe, that's the whole point, not to find closure, but to learn how to live inside the question. So what is Three-Eye Atlas teaching us, really? Perhaps that light itself is not just illumination, but communication. The universe speaks to us through radiance, through the hum of electromagnetic waves that carry stories across billions of years. And sometimes those stories are clear, other times they're written in codes we haven't yet learned to read. Three-Eye Atlas may be one of those codes, not a message to us, but a message through us, testing whether we are capable of listening without rushing to translate. And, maybe that's why its light feels almost alive, because in it, there's the sense of an invitation, a call not for explanation, but for participation. It says, come closer, not to conquer, but to witness. It says, what if light isn't just energy, but empathy, a way the universe reminds itself that it can be seen? You know, sometimes I think that's the secret of the cosmos, that visibility itself is an act of generosity, that every photon is a gift, a small offering from the unknown, saying, here, take this, see me. Three-Eye Atlas gave us that gift, and we, in turn, gave it meaning by paying attention. And yet, well, even now, the meaning keeps shifting. Some call it a natural phenomenon, others a new kind of cosmic process. A few, the dreamers, the ones who sit up at night and let silence teach them, and think it might be something more. Not technology, exactly, but intention, as if the object itself knew how to glow in a way that would force awareness. A silent teaching, written in the spectrum of blue. But perhaps intention doesn't need intelligence to exist. Maybe the universe itself is the intelligent one, vast, recursive, creative, experimenting through matter, through motion, through light. Maybe everything that confuses us is simply part of a larger pattern we're not yet big enough to see. And, isn't that thought strangely comforting? That the mysteries aren't mistakes, but milestones. That the unexplained isn't chaos, but order we haven't learned to read. Science has always advanced not by eliminating mystery, but by befriending it. Every breakthrough is born from awe that refused to give up. We often think of progress as linear, a ladder climbing upward towards some ultimate understanding. But the truth is, it's cyclical. We return again and again to the same questions, each time from a slightly higher orbit. 3i Atlas will fade, yes, but its mystery will orbit with us, pulling our curiosity forward like gravity itself. And perhaps, that's the most profound legacy of all, that it reminds us what science really is, not a set of answers, but a posture, a way of standing before the unknown without collapsing into fear. The courage to say, I don't know yet, and to mean it as an act of faith. Loeb once said that when he looks through a telescope, he doesn't see emptiness, he sees potential. Every point of light is a possibility waiting to become experience. Maybe then, the unexplained energy of 3i, Atlas, is the universe's way of reminding us to look at ourselves that way too. To see potential where others see mystery. To believe that curiosity itself is a kind of light. And, if that's true, then perhaps we've been reading the story of 3i Atlas backward. Perhaps the question was never, what powers it? But, what does it awaken in us? The glow we chased across the sky, maybe that was only half the light. The rest of it is in here, in the part of us that refused to stop wondering. Because that's what light does, it awakens. It moves through the dark not to erase it, but to make it visible. Every photon from that distant traveller carried a small reminder that knowledge is only half the story, and the other half is wonder. It's not just the data, it's the dreaming that turns discovery into meaning. And so, as the instruments shut down their last recordings, as the final papers are written and filed away, we are left not with conclusions, but with questions bright as stars. 3i Atlas has reminded us that science and awe are the same thing spoken in two different dialects. That discovery is not about what we know, but about how deeply we are willing to listen. Maybe that's the true unexplained energy Loeb spoke of, not in the comet, but in us. The energy of curiosity, of imagination, of wonder that refuses to dim even when the evidence fades. The kind of energy that keeps humanity moving forward, generation after generation, toward the next unknown light. And somewhere in that blue glow that once shimmered near the sun, the question remains unbroken, undimmed, waiting. Because the story of 3i Atlas doesn't end with what it was, it begins with what it has inspired. And out there, in the quiet distance of space, another light is stirring, another mystery forming, another chance for us to ask, once again, what if the universe is not asking to be solved, but to be understood? And so, as we stand beneath the same sky that once carried the blue flame of 3i Atlas, there's a strange quiet that settles, a quiet not of absence, but of expectation. Because every mystery, leaves a kind of gravity behind it, a pull on the mind that doesn't fade when the light does. And maybe that's what we're feeling now, the slow tug of curiosity, drawing us forward into the next chapter of the universe's conversation. You see, 3i Atlas may have vanished from our instruments, but it hasn't left our imagination. Its echo still hums through equations, through late-night discussions, through the faint static between what we know and what we feel. The scientists who tracked its flight still meet in quiet corners of observatories and conference halls. They rewatch the data, those impossible gradients of blue, the acceleration that defied thermodynamics, the curves that rose too steeply to fit any known model. And, you can hear it in their voices when they speak, that delicate blend of disbelief and reverence. It's the tone people use when they've seen something that refuses to leave them. Well, what if, and this is where it gets fascinating, what if 3i Atlas wasn't an anomaly at all, but the beginning of a pattern too vast for a single generation to perceive? There are hints now, faint and scattered, of other objects, other wanderers with spectral behaviors that shimmer just beyond the expected. Maybe they're connected. Maybe the universe, in its quiet way, is sending us a sequence, a rhythm of arrivals, one blue flame after another. And, that thought, that possibility changes how you see everything. Because suddenly, 3i Atlas isn't a solitary event. It's a signpost. It's a reminder that we're standing in a cosmic network of signals spread across centuries and light years. Some arrive as comets, some as gamma bursts, some as patterns in the cosmic microwave background. And we, small and listening, are just beginning to notice the rhythm. You know, there's something beautifully human about that. We're pattern-seeking creatures, wired to find meaning in the random, stories in the stars. It's what kept our ancestors alive and, it's what keeps our scientists awake. We can't help it. When the universe hums, we lean closer to listen. And maybe that's the next step, listening, truly listening. Because for all our instruments and algorithms, the act of discovery still depends on intuition, on imagination. The numbers tell us what is, but it's the wonder that tells us what might be. The physicist and the poet, they both chase the same horizon, only with different languages. And 3i Atlas, it spoke fluently in both. Somewhere, in the deep data archives of 2025, there's a moment, a single frame, when the object flared brighter than anything nearby. For a fraction of a second, its luminosity matched the sun's corona, then fell again. No one has yet explained it. Some call it a glitch, others an artifact of calibration. But, well, others whisper that maybe it was the object itself responding, however briefly, to the light of the star it passed, like a bow answering a violin. It's not proof, it's not even theory, but it's an image that stays with you. Because if the universe is a kind of symphony, then maybe we've just heard a single note, the first of many. Maybe every interstellar visitor is part of that melody, each carrying a variation, a phrase, a tone, written in its trajectory and light. And, perhaps, the most haunting idea of all is this. What if the melody is meant to be completed not by stars, but by us, not just observed, but participated in? Maybe the act of noticing the attention we give is the missing harmony. We, the observers, are not outside the song. We are part of its unfolding. That's a thought that used to belong to philosophers. Now, it's beginning to drift into the language of cosmology. Some researchers speak of consciousness not as a byproduct of the universe, but as one of its instruments, a way for the cosmos to perceive itself. And 3i Atlas, strange, defiant, luminous, might be a reminder of that. It's not that it came for us, but that we were capable of seeing it at all. That, says something profound about what awareness is. So maybe that's the deeper experiment happening here, not in the object, but in us. To test whether human curiosity can keep up with the universe's imagination, whether our desire to know can grow wide enough to embrace what can't yet be known. And, well, it's not easy. Wonder never is. It demands vulnerability. It asks you to admit that your understanding, no matter how advanced, how precise, will always be partial. But in that humility, something expands. You begin to see that the universe doesn't need to be conquered or categorized to be meaningful. It's meaningful simply because it is. Avi Loeb once described science as the act of falling in love with reality without needing it to make sense. And maybe that's exactly where we are now, in love with something vast, mysterious, and gloriously confusing. That's the beauty of these interstellar encounters. They don't resolve, they reveal. They leave us standing in that exquisite space between fear and fascination, the place where true understanding begins. And, if you look at it that way, then maybe 3i Atlas didn't just travel through space, it traveled through consciousness. It crossed from matter into meaning, from motion into metaphor. It reminded us that exploration is not just physical, it's emotional. Every new discovery stretches not only our knowledge, but our capacity for awe. Well, imagine for a moment if the same event had occurred centuries ago, before telescopes, before satellites, before the language of spectroscopy. People would have called it divine, a messenger, a sign, and in some strange way, maybe they wouldn't have been wrong. Because whether we call it physics or miracle, the effect is the same. It awakens us. It makes us look up. It connects us to something larger than ourselves. So perhaps the real progress isn't that we've stopped seeing the divine in the universe. It's that we've learned to find divinity in understanding itself. To see that every act of discovery is also an act of reverence. That to measure light is to worship it in a quiet, empirical way. And, that brings us somewhere new, somewhere almost philosophical, but grounded in observation. Because what if, just what if, the universe wants to be known? What if curiosity isn't just human, but cosmic, a property woven into the very structure of existence? If matter evolves toward awareness, and awareness evolves toward wonder, then maybe the act of wondering is the universe continuing its own creation. That would mean 3i Atlas wasn't just an interstellar traveler. It was a reminder of our role to witness, to feel, to question. We are not the center of the story, no, but we are the ones through whom the story becomes conscious. Without eyes to see, the blue would still shine, but it would shine unseen. And that, would make all the difference. So here we are, after its passing, left with a choice. To file it away as anomaly, or to treat it as an invitation. To keep watching, not just with our instruments, but with our imaginations, because somewhere out there, beyond the reach of our senses, another visitor is already on its way. Maybe smaller, maybe stranger, maybe even more impossible. And when it comes, whether next year or next century, the question won't be, what is it? But what are we ready to see? Because, well, that's the thing about wonder. It meets you at the level of your openness. The deeper your awe, the clearer your vision. And perhaps that's where we're headed next, into an age where science doesn't just observe the universe, but listens to it. Where every spark of light, every anomaly, every interstellar wanderer is part of an ongoing conversation, one that began long before us and will continue long after. And, if we're quiet enough, if we're patient enough, maybe we'll begin to hear it more clearly, that slow, radiant whisper that says, in the language of light itself, keep going, keep looking, keep listening. And so, as the echoes of that whisper fade into the quiet vastness of thought, humanity stands once again at the edge of something it cannot quite name. The mystery of 3i Atlas has passed into history, yes, but, well, its afterglow remains not just in data or models or archived telescope logs, but in something subtler, more enduring, a shift in the way we listen. Because the more we learn, the more we begin to suspect that listening itself, deep, patient, open listening, might be the most powerful form of discovery there is. And, well, that's the thing about silence, you see. It's never truly empty. It hums with potential, like the pause between two musical notes, holding within it the shape of what's yet to come. The universe, in that sense, doesn't stop speaking just because we can't always hear it. It changes its language. Sometimes it speaks in radio waves, sometimes in the slow drift of galaxies, sometimes, perhaps, in the shimmering passage of a blue interstellar traveler that no one expected. You see, 3i Atlas didn't just challenge our equations, it changed our posture toward the cosmos. For centuries we've looked outward with certainty, measuring, labeling, explaining. But now, after this strange encounter, we've begun to look differently, softer, with more wonder than pride. It's not just science anymore, it's listening as devotion, observation as reverence. Well, that's how progress really happens, not just through new technology, but through new humility. The deeper we look, the quieter we must become. Because somewhere in that stillness between knowing and not knowing, the universe reveals itself not as a set of answers, but as a series of questions that lead us inward as much as outward. And, that's where it gets interesting. Because if listening is a kind of discovery, then perhaps consciousness, our awareness, is the tool the cosmos invented to hear itself. We are not separate from the universe, but rather, we are its ability to reflect, its way of perceiving its own beauty. When we gaze at something like 3i Atlas, it's not just our curiosity reaching out, it's the universe turning its gaze back through us. That thought, it's humbling, It's dizzying, because it means that wonder isn't a human invention, it's a cosmic instinct. The stars feel it too, in their own way, burning themselves into brilliance just to be seen. The galaxies expand, not out of emptiness, but out of longing, a kind of gravitational yearning to make space for perception. So maybe everything that exists is participating in one grand act of awareness. Every photon, every atom, every mind, all part of the same awakening. And perhaps that's why we feel so deeply moved by things we can't explain. Because in those moments when mystery exceeds our grasp, something ancient stirs in us. It's as if the universe remembers itself through our awe. The blue light of 3I Atlas was not just strange, it was familiar in a way we couldn't articulate. It resonated, not just with instruments, but with intuition. Maybe that's the beginning of a new kind of science, one that doesn't separate reason from wonder. For too long, we've thought of emotion as something that clouds understanding. But what if it's the opposite? What if emotion is the mind's way of recognizing truth before it can be described? Or as intuition, curiosity as empathy. That could change everything about how we explore the cosmos. And, we're beginning to see hints of it already. Young scientists, the ones who grew up watching the footage of 3I Atlas, they talk differently now. Their research papers still use the language of mathematics, yes, but between the lines there's something more tender. Words like beauty and elegance return to the discourse. You can hear it in the way they describe their work, not as control, but as conversation, not as conquest, but as communion. Well, perhaps that's the quiet revolution 3I Atlas started. It reintroduced awe as a valid form of inquiry. It reminded us that understanding is not the same as reduction. You can know a phenomenon completely and still fail to feel its meaning. But when you approach with wonder, when you allow the mystery to breathe, knowledge becomes something alive. And, I suppose that's what we've been missing all along. The sense that science isn't separate from soul, that the act of discovery is, at its core, an act of love. Love for truth, love for the infinite, love for the fragile fact that we exist at all. When 3I Atlas flared blue near the sun, it wasn't just an object reflecting light, it was an invitation to remember that love, the love that drives us to look up, again and again, despite the vastness. It's strange, isn't it? How a single object, a fragment of stone and ice from another star, can ripple through the entire consciousness of a species. But that's what it did. It changed the tone of our relationship with the cosmos. We stopped asking, what is out there? And began to ask, what does it mean that we can see it? That shift from analysis to awareness is quiet but profound. It's the difference between staring at a horizon and realizing you are part of it. And that's, the real journey, not through space, but through perception. Because as we peer deeper into the cosmos, what we're really exploring are the boundaries of our own awareness. Every new telescope, every interstellar discovery, pushes that boundary outward a little more, but it also, pulls us inward toward a deeper sense of belonging. There's a kind of poetic symmetry in it. The further we look, the more we realize how rare it is that we can look at all. That consciousness, in all its fragility, is the rarest material in the universe, and yet it's also the most luminous. When we understand that, we begin to see exploration differently, not as expansion, but as expression, the universe unfolding through us, not for us. And, maybe that's why, even now, long after 3I Atlas has faded into the background of stars, we can still feel its presence. Because what it truly illuminated was not just the physics of light, but the possibility that the universe is aware of itself through our wonder, through our silence, through our relentless curiosity. So perhaps the real discovery isn't that we found a new kind of object, but that we found a new way of seeing, a way that blurs the boundaries between knowledge and reverence, between science and spirit. It's not just the cosmos we're learning to hear, it's ourselves. And maybe, that's what's next. Maybe that's what the future of exploration will be, not louder, but quieter, not faster, but deeper. A science that doesn't just reach into space, but listens to the echo it leaves within us. because the universe doesn't end where our instruments fail. It continues inside our perception, expanding through imagination, through empathy, through that small, persistent voice that says, "There's more." Well, perhaps that's where we're heading now, toward a time when discovery feels less like conquest and more like communion, a time when we no longer separate what we know from what we feel, when observation becomes participation, when understanding becomes belonging, and somewhere, beyond the horizon of our current knowledge, another signal is already forming, faint, fragile, waiting for us to listen not just with our machines, but with our hearts.